Thank you very much for the introduction and the opportunity to speak. I'd like to shift gear a little bit because most of what you heard so far is about text and translating text. What I will be talking about is, of course, the challenge that we have in Europe, that Europe is multilingual, inherently multilingual, and not everything we do is text. We communicate, really, and ultimately what this problem is about is how do we integrate people who live in a different language environment. And language environments really have different forms of expression. They can be textual, but they can also be texting, and they can be visual in road signs. They can be spoken when we give lectures or when we make telephone calls. And all of these are impediments in order to integrate a society, because if you have a breakdown in communication in any one of these dimensions, you make it difficult for people to do business. Now, Europe is obviously the most advanced and the most ambitious in terms of integrating people from different cultures and languages. And hence, I think it is just a wonderful effort to make this happen in all parts of society, to bring together people who are really speaking different languages and writing in different languages. Now, we have these 23 official languages, in addition, of course, dialects and accents, etc., which makes this excruciatingly difficult. So there are different solutions and different things people propose as an answer to this. The first one and the most common one is, let's not worry about it, let's just all speak in English. And guess what? I don't know where you are all coming from. I'm originally from Germany, but I'm speaking to you in English. So we are doing this right here, that we're in fact agreeing on a common language, which is English de facto. But, you know, if we look at this, is this a sensible solution for Europe? Then we realize quite quickly that, in fact, actually, on average, only 40% of people speak English well enough that they can conduct business in English. So hence, we're already generating a sort of like in the Roman Empire, a situation of the haves and have-nots. Those who have an education, they can participate, and those who don't, they don't. And all of this is even worse by the fact that the main common language that we're speaking is now even leaving the European Union and Commission. So we're all now communicating in a language that at least the main country isn't even part of anymore. So it's a horrible situation, and in fact it screams for some kind of answer that is more pervasive and more obvious and more usable by everybody. Now, to make matters even worse, as I said before, it's not just text, but, you know, expression comes in all forms. We have spoken language, we have gestures, we have images. This is my favorite one here that I snapped in China, where you run up to a sign that says no entry for tourists, but you can't read the sign. So what do you do in these situations? Then we're all texting, and the texting is no longer pretty well standardized English, but it is this messy thing that people produce, and our youngsters have to explain to us what it actually even means. So how is it done in Europe currently is, again, a wonderful, enormous effort. The European Parliament and the European Commission and the European organizations make the effort of producing translations in many languages. For those of you in the business of doing that, don't worry, you will still have a job, because none of this will really what I will be talking about to you will threaten your jobs, because you're doing it so much better than the machines right now, and you're adding a human element to it that the machines cannot bring. However, that still leaves the whole rest of us, the rest of the society, that simply cannot afford or cannot take advantage of the services that are being provided. One such service and such a situation is in our universities. At the University of Karlsruhe, the KIT, we have the situation that we have international students, and we're limited by language because they don't want to learn German out of all languages. And so we are missing out on some talent and some international exchange that is otherwise very important and needed for society. So we were starting many years ago already on building interpreting machines. It's a long labor of love for me, where we started in the late 70s or early 80s already thinking about machines that could interpret. And if you think about this, it requires multiple components. It requires the automatic conversion of speech into text. It requires the machine translation, the translation of one language into another. And it requires, in many cases, also how you present this output in terms of synthesis or in terms of visual information and so on. Heads-up displays, whatever. So there are many, many different forms here. Now, if you want to have a dialogue, of course, you have to do this in multiple languages in both directions. And just for a simple little interpreting device, you already need something like 6 different components that have to build, and they are actually complex to build. We started with this in the early 90s. Here you see me with more hair. Speaking into a system we developed in the early 90s, was the first of its kind really in Europe and US, where we had a consortium with the Japanese and Germans and so forth, where we tried to build these things via video conferencing of a very limited vocabulary and limited syntax. Fast forward to today, now we're beginning to have these systems, and the first question that arises, why is it so hard? Why did it take so long? And the thing that has already been mentioned, it's the enormous ambiguity of language, that at each levels you have confusions. Acoustics can mean different things, semantics can mean different things, syntax mean different things. And for all of these situations, you really need to have a very good model of the context, of the situation that you're in, what is it you're intending to say in order to actually express it correctly in the other language. And this contextual knowledge and so forth is very, very hard to develop. So for many, many years we tried. We built rule-based systems, etc. And most of the time it leads to goofy translations, goofy transcriptions that people laugh about. And again, it's this lack of information that makes it very difficult. So the hard lesson learned over many decades is you cannot do it by programming rules. You must have machine learning so that on the data that we have, on the models we have, on the environment you have, you now build a learning algorithm that really learns from this environment instead of programming all these facts in. Also, things change all the time, so it must be learning and adapting. That was something we recognized early on. Now, the second problem is, of course, the ambiguity that I mentioned. The ambiguity also requires a different kind of model than hard-coded rules. And it requires statistics, neural activation, scores, something fuzzy that can tell you it could be this, it could be that. And by considering different models, I make a decision in the end by combining things. And we do this all the time in our brains. That leads to these jokes that we laugh about because our brains naturally make conclusions based on the aggregate of all of these models and these maybes that we have in our heads. Now, if you have these ambiguities in these scores and the machine learning, you have to do this on the actual data in the world. So we're critically dependent on running this over lots and lots of data to really capture the essence of what happens in the world so that our automatic learning machines can then build the models and deploy them in the actual application. Hence, the crucial message and take-home message, it's essential to have data for good performance and a lot of computing to build these models automatically. And as it was said in the previous talks already, you can actually build. The talk by SAP was very poignant about this because you can actually beat the best translation systems or recognition systems that might be out there by Google or whoever, if you really build models specifically for your domain and specifically in your environment. Why? Because then we understand the context better, we understand the modeling, the meanings, etc. better. So again, it depends very crucially on the data in the actual situation. Now, here's a few of the models that we used. Again, no need to understand the details, but just to show you and to brag a little that we are actually already building neural networks in the late 80s. And if you look at what's today coming out in neural networks, it turns out it's exactly the same models as back then, except that we have huge networks now with many, many units, many more units, and a lot more data. So when we started with this, we had 0.1 amount of training data. Now we have many thousands of hours of training data, the number of weights went up by orders of 4 or 5 orders of magnitude easily. The only thing that hasn't changed is the amount of time that we as researchers are willing to wait for results, which is still 1 week, because you have to publish your papers, and there is already the limitation in much of what we do. More data, more computing, and you will see better results. The same is in machine translation. Again, early models in the 80s, already recurrent neural network models, statistical models that have been developed over the years, and now we're full force back into neural networks with the recent advantages of recurrent neural networks and machine translations that deliver now enormous improvements and fantastic results. Now, is the data story positive? Yes, we're already actually building all of our models on more data than a human will have spoken in their lifetime. So we're training all of these systems on gigaword corpora, and the human being in a lifetime speaks about 500 million words. And again, the trend is even further in that direction, that this will improve. However, much of this is not context, so most of the available data is obviously very generic, and hence, again, the important need for having more specific, more adapted data in the different domains of the users. Now, to show you a few of these things that we did, I will walk you through very quickly some of these applications that we built. And again, the take-home message in each one of them is we were successful because we could build them in the actual domain for the actual user. After 20 years of research on these early interpretation systems, we were, for example, successful in 2009 to build the world's first, I'm proud to say, speech translator on a phone. That was when the iPhone G3S came out. We were able to squeeze an entire system with 40,000 word vocabularies into a telephone without network connection, and actually built an app that was distributed over the iTunes store, and in fact,
I took this amazing trip to Spain after college.
Led to many commercials by Apple.
I checked out hostels before booking them. Shared pictures as I went. My mom loved that. And I even downloaded this app, which became my personal translator. Where's the train station?
¿Dónde está la estación de tren?
All I really needed was my iPhone and my passport.
So it was the first app in which this was actually possible, and Apple made many commercials actually selling iPhones by the enormous potential of language independence that it would provide. Following the success, we also had a chance to work at Facebook with our team. I started the language technology group at Facebook to build now translation systems for posts. So if you go to Facebook and you see translation, it doesn't always work very well, but we were able to, in a relatively short time, to actually build translation systems for the texting and for the kind of posting that people do on Facebook, and here you see a little bit of an example for it. The problem is the one that I mentioned before. People don't really speak or don't really write clear text. You have these happy birthday and with emoticons and whatnot, and